Hello everybody, my name is Yassin Rekik. I'm professor at the University of Applied Science in Geneva, and I will present a project called Glasgow for a Glasgow Coma scale simulator, and this project is developed in collaboration with my colleague Stéphane Malanda, here present, and also Dominique Carrea de Oliveira from the HES-SO Canton de Vaud. So, first, let me explain a little bit what is this Glasgow scale. So, the Glasgow Coma scale is a neurological instrument in order to measure the degree of consciousness for patients, and it's a way to communicate easily between the many intervenients in emergency situations. So, when, for example, there is a situation of emergency between nurses, doctors, rescuers, etc., they can rapidly exchange their evaluation of the situation just by giving a number. It's 7, it's 10, and it's very easier than explaining half an hour about the situation, because we are in a situation of emergency and we need to go fast. It's an international scale. This is also very beneficial, so you can have the same evaluation wherever you are all over the world. This scale is based on 3 main, let's say, analysis of the A, movement and situation. Of course, I'm sorry, I'm not doctors, I'm not practitioners, I'm trying to explain what people explained to me at the beginning of the project. The second thing is everything which is verbal exchange, how he answer questions, can he situate himself, etc. So it's what we call verbal response. And we have also motor response. There is some analysis we can do in order to see if he reacts normally or not to some stimulus. And based on these 3 evaluations, we get to a score. And of course, this score, if is it between 13 and 15, the situation is very okay. If is it between 9 and 12, the situation starts becoming a little bit, not normal, but we have to do something. And if is it lower than 8, we are in a critical situation and we have to take many decisions rapidly. Okay, so this is the scale. How this scale is teaching now, of course, this scale, as I said, is used by a lot of people, doctors, nurses, firemen, rescuers, etc. So it is, they are supposed to be trained on making such analysis and such diagnostic and give a score for all this curriculum. But the problem is that in general, the topic is so large and the variation is so huge, they always make some simulation using themselves as figurants, as actors, and they try to simulate 10, 12 situations. And it's very basic, and it is not enough at all to get all the parameters and to take into account all the variation of the problem. So let me give you just one example. You can teach the theory for 1 year, and then you are faced with the patient and he don't react, and it is not because of the situation, it's not because he is, for example, paralyzed, or he is older woman and he cannot react. So the diagnostic will be completely different. And all these nuances and shaders and subtleties are not easy to teach. So the idea is that we have been contacted by a teacher from the École Santé in Lausanne, and they said, can you do it better by building a simulation for that? So the first step, so the objective was to first build a simulation in order to put the student, the learner, in a situation and to be able to realize this diagnostic and to be able to give a score at the end. This is the first step. Then, of course, because I'm working on gamification and game development since now 20 years, I try to introduce some gamification, and I asked them, can we make it a little bit more attractive, etc., by introducing some gamification? So, of course, as usual, they said, it's okay, but first let's focus on the simulation, and then we can see. So we went this step-by-step project. So we say, okay, we will develop the simulation first, very seriously, very realistically, and then we will tackle two gamification steps. In the first one, we will introduce gamification aspects who are, let's say, classical. All bodies, everyone working in gamification know them. I will explain them later. But in the second phase, I suggested to go out from the classical context of the hospital or etc. and to develop something completely new. We are in the city, we are doing missions, and in order to make the quests and the missions in the city, you have to rescue some people in order to get information, to get some keys, to get some hints, and this will help you to go faster, to go more in your missions, etc. So this is the, let's say, the contracts with our, let's say, end users. So we started develop them. So we developed a kind of modelization of our simulator. So the idea is to allow the practitioner or the teacher to define scenarios, and the scenario described. Can we have interaction with parents of the patient? How to model the patient and all his reactions to the stimulus, and also how to get access to the files and records of the patient's age, situation, etc., medical information, etc. And then the gamer will take into account. I'm sorry. Bon, j'ai touché quelque chose. Okay. Sorry. Then the gamer will start, and the end results of his game or his simulation is to first have a Glasgow score. He has to suggest a Glasgow score, but there is also another things, because when we discuss with teacher, they said what is important not only to get the score, but to decide what is the implication of this score. And they have what they call something they call it the SCAR, is situation, context, analysis, and reactions. So the idea is to describe for any doctor or practitioner the situation of the patient, the context. Is it, for example, the third diagnostic, the second day, the third day, etc. So this is what they call the context. Then you have to give your analysis. He is at 9, at 6, at 7, at whatever your score, and then you have to suggest. We should, for example, make intubation. We should do that and that and that. And this process has to be mastered by this prototype. So of course we make a model for that, because our idea is to be able to generate as much situation as possible. So instead of developing fixed scenarios, we give the opportunity for the learner, for the teacher, to describe their own scenario, and we model that in JSON format, and then it is absorbed by our simulator, and we can have new simulation each day if the teacher can describe the new scenarios. Okay, so it's we try to make it very generic. So now the situation is that the simulation part is working, let's say, well. I say let's say well because we didn't make real tests until now. Only teachers use it, test it, and we are supposed to test it in the next semester at September. Okay, so the idea is to be in an hospital room. We have the patients, we have one of the parents, etc. Don't take attention to the bad modeling of the patient, etc. This is only the first prototype. Now we have nicer and more realistic prototypes, etc. of the patients and the parents. Then when we have also is that we can interact with the patients, we can interact with the parents. At the end, you have to decide from the 3 levels of scoring, compute the global score, and then you have also to decide in the SCAR tool in order to take decision what you have to do in this situation. At the end, any learner has a global evaluation at the end. Did you do it good or bad, etc., etc. Okay. So as I said, this is okay. Again, I have to mention the difficulty to model a patient and to be as realistic as possible. Of course, it's a small project. I don't have the budget to hire 10 graphics in order to have a very realistic patient. So what we do is that we use reusable assets from Unity, etc. But what we did is to develop 3 modules on that, focusing on the 3 analyses we have to do. So we developed something focusing only on eyes, and we develop a module allowing us to define how the eyes will react and how we can trigger that, etc. So this is in order to focus on eye reactions and situation. The second thing is all the verbal exchange with the patients, and we do it using artificial intelligence, using bots, and we're using also a tool in order to detect keywords in the questions, and then we automatically generate answers. And of course, the answers depends on the score we are targeting. So if, for example, the teacher says, in this situation, the targeted score is 8. So we are supposed to have incoherent answers. So we have to produce incoherent answers. Not coherent, it's the opposite, etc. Okay, I will finish in 2 minutes. And the third thing is that we have developed a lot of animations in order to simulate also the reaction of patients to physical stimulus. And also in this case, we develop good ones and wrong ones, because sometimes it happens, in a lot of time it happens. Okay, certain things, we started introducing some gamifications, like for example, time constraints, scoring, rewards, final evaluation, and also we noticed that students and teachers like these aspects of using IT objects. It's by itself, it's funny for them, okay? And the second step, but we didn't start that, we are also just brainstorming on it, and we start making the models, etc., and the story, but we didn't start the implementation, is, as I said, to transform all that as a mission in the city, and you will make some encounters, and every time you encounter someone, he is in a critical situation, you have to save them in order to get some information, some hints, some code, etc., and it will allows you to continue your mission. It is intended to be more fun. So this is the situation, and now, as I said, the simulation mode worked very well. Gamification level 1 is also in progress, but more or less achieved. And as I said, we will test that next semester with the real students from École de Santé Lausanne, and the future will be the gamification level. Thank you very much for your attention.
Thank you for your presentation. Unfortunately, we have no time for questions.
No problem, it's better for me to escape questions. No, but we can discuss in the break. So I'm here for the whole day and tomorrow also. Thank you very much.